Cool. So I'm just doing some basic ass coding that I do throughout the day. I'm not going to show my camera because somehow that like affects my mental when I'm working on code. Or from working with students very frequently, I just don't care about what someone looks like when I'm helping them work on a problem. All I really need is to be able to hear them and to see their code. So I'm going to take the same approach with myself. I'm going to try and talk through some things while I work on some things. I might get quiet for a while I'm working on some stuff, but I've got a lot of code I need to write that I've been putting off. And better to get started sooner rather than later. I need to update something on my channel before I really get started here. Science and technology. I don't have a generic programming playlist yet. We're gonna create a new playlist. We're gonna call it actually we'll call it computer science. Put tags on later. Okay. Now that that's good to go, I'm going to pull up the chat. And now we're ready to really fire off. Let's see how this looks when I do the split. Okay, good. Everything's pretty nice and legible. So now the title of this stream says Refactoring C, and I believe the thumbnail says something like multi-threaded network sockets in C. And you're probably wondering, the code on screen has nothing to do with this. So why is it here? Well, I'll show you. So I have this idea that I want to work on, and it's inspired off of an article or a chapter rather of the book VX Underground Presents Black Mass. And it's Black Mass Volume 1 specifically. And the chapter in the book that I'm interested in is about something called the Red King Hive Mind. So what is this? What is a Red King Hive Mind? What is a botnet? What is a bot? What is a net? Put them together. What is that? If you're a noob, you just hear about these things. You don't really know what they are, but you know they're scary sounding because of the way that people talk about them. But at the end of the day, if you really understand programming and computers, you know that a bot is just an automated program that does something on repeat without much intervention. And you know that a net or a network is just a interconnection of points on a graph. You have, for instance, if you have two computers linked together, that's a small network. Not much of a network, but it is a network. So if a bot is an automated program and a network is just a series of interconnected nodes, then a botnet must be a series of interconnected automated programs, which you get far enough into programming and you start playing around with things, and certain things are able to be done more easily over time, because one of the principles of automation is simply writing good code. What is good code? Well, we're going to do some good coding today. I'm going to show you what I think good coding is, or what are good practices in refactoring. So wow, we got a lot of viewers. Holy shit. So I'm gonna act like I'm talking to a class. And I will apologize in advance, because at some point during my lecture, I'm going to have to take my dog out to pee. She's an old girl. She's bedbound mostly, and needs help getting outside. She's able to take care of herself once she's out there, but, she just needs me or someone to carry her from the bed to the grass, and then she can walk around and get some exercise and all that kind of stuff. I do apologize also if the stream drops out. It looked like it had been doing okay, but we're sitting at about 20% drop frames. So, I'm not doing much right now, so it's not really affecting your experience, hopefully. But just be aware that I am recording this locally, so I will make an effort to re-upload it later on. So no worries there. We're talking about doing good coding, and my idea of what good refactoring practices are. Because when you're writing code, like, let's use a real example. Like, so in the beginning, right? Like, let's take a step back all the way to CS 101. Let's take it back to Genesis in the fucking Bible. In the beginning, there was nothing. And then God said, include stdio.h. In fact, I'm going to turn off Copilot for this. In the beginning, God said, include standard.io.h. That's what stdio stands for. Standard input output. And you're like, okay, so pound include, what does this do? Why is the file name in angle brackets? And what is a .h file, right? So a .h file is a header file, and is often a list of declarations or definitions. It's bad practice nowadays considered to put definitions in the .h files, but a lot of libraries actually do this thing where they dump functions into the .h file so that it's like one header include, which simplifies deployment in a lot of cases, but there may or may not be good reasons that you want to actually build object files for the functions that you write in C. So, and these are things that like people who work in Go and Rust and shit probably don't even have to fucking think about, but this is a thing in C. So, and C++ for that matter. So if you think in terms of .h files being a list of functions that you have access to, right? As you're coming over from another language, you kind of have the benefit possibly of having this idea of libraries and APIs under your belt already. For instance, I did Java senior year of high school, and one of the reasons I don't like working in Java is I feel like they just give you everything out of the box, and it's not fun. You don't have to solve anything yourself. You don't have to think about anything. It's all given to you. You can just focus on building things rather than like being super clever. And part of the fun of programming is kind of like not reinventing the wheel necessarily, but getting a chance to look at the way the wheel was made to begin with, and examine that process and see, is it possible that we could have made the wheel better? And it's not to say that, everybody is successful in this endeavor, but, for 1 out of every 1,000,000 people who take a stab at that problem, they may or may not actually find something better. We wouldn't have new programming languages today if people weren't actively doing this in every fucking domain, right? So I'm getting away from the point of refactoring. So in the beginning, God said include standard input output, and then there was int main. We're not even passing arguments, but I want you to get into the habit of doing this. Int argc char star argv bracket bracket. Or another thing you could do is, instead of doing that, you can also declare argv as a double pointer, and that's effectively the same thing. So what is int? What is main? What is argc? What is star argv bracket bracket? And what is star star argv, right? I'm taking y'all through a lot right now. So for those who don't know what a data type is, or a primitive data type, integer or int being like the most ubiquitous next to char, possibly, and float and double. You have all these different primitive data types. You've got int, you've got char, you've got technically void's not a data type, but sometimes it can be considered a data type. You've got double, you've got float. I'm having trouble thinking of any others off the top. Long, short, etc. So you've got all of these different data types, right? And out of these primitive data types emerge more complicated things like arrays or strings and etc. So you have to start here. You have to know what these are. And we create this function that starts off with the line int main, because the first part indicates the return type of the function. That is to say, what does it mean for a function to return something? Well, it means that the function computes some value and then gives it back to some other part of the program that called the function to begin with. What does it mean to call a function? Calling a function is like running a function or executing a program. You can think of a function almost like a small program itself, right? So if you step forward and take these ideas, now we have int main. So the main is the name of the function. So if it returns int and its name is main, and you may or may not have parameters here. So what is a parameter? Parameter is stuff that goes into parentheses. What goes into parentheses? Well, let's say you're like calling a function, like you're writing a function in math, right? Like let's say you're doing something like f of x equals x plus 5 or some dumb shit like that, right? So the parameter to f in this case is going to be x. And in a similar way, when you're writing a function, you have parameters, or may not have parameters, that you pass to it. Sometimes a function has no parameters and all it does is just some predefined stuff that you've already thought of ahead of time. Now, somewhere along the way during your programming journey, you're going to become aware of global variables. And there's good discussion and arguments on whether or not you need to actually do these things or use these things. And a lot of it is going to be context specific. You might find that it's easier to do it one way or another just based on how your brain works. But from a pure function programming perspective, it's a good practice to actually try and write functions in a way that accept things as parameters rather than relying upon a global variable. Because if you have some global variable that's shared by other functions and you start getting into multi-threading, then you're going to have to start using mutexes, and you might even have to use a mutex either way. So it's a good idea to write things in a way where any sort of global state that you might possibly be managing can get passed around from function to function so that no functions collide, in other words, so that you're always passing the state from one thing to another. And this way, there's like really not much of a chance of confusion that could occur during the execution, because you'll be able to always trace down and figure out where something goes wrong. And that's a very powerful thing, because things are going to go wrong very often during your programming journey. You're going to break things. You're going to not know how things work at first. You're going to, there's so much stuff like that that you just have to push through. And being in the mode of solving problems and being okay with being wrong every so often, or even more often than not, until you get something correct or understand how something works. And you understand when you're able to explain it, write code that follows your explanation and comes to the same result that your initial assumptions made. But very often you're going to write code that works and you don't understand why it works at first. Sometimes you just accidentally flip things around and get things right, and then you're like, what the fuck? So we have this int main, and in the very beginning, even before print hello world, right? Like you want to return 0. So when we talk about a function returning something, this is what I mean. We return a actual value, because if the return type of main is int, you have to return an integer. And if you want to tell the operating system, which is the thing that calls main to begin with when your code's compiled and you run it, you want to tell the operating system everything was good, no problems, then you return 0. Now, another thing that we can do to be more explicit, which is often a good idea, we're going to include standard library, which includes a lot of definitions, including exit success, which is defined as 0. But it's a good idea to avoid hard coding things. Now, what's the difference between this and what I just had? We had 0 here, right? You could consider this kind of a light form of hard coding, because to the outside observer who knows nothing about computers, this doesn't really explain what it is. Now you're saying, well, anyone working with code is obviously knowledgeable about computers, but how many people in the computer world, including programmers, even are aware of the fact that main, like returning 0 to the operating system indicates success? Because it's kind of counterintuitive at times. But you have to think of it in terms of, did the program return error? And if it returns anything other than 0, then that indicates error, right? So printf hello world, right? Super basic program. Now, what do I mean by good refactoring? Well, you could shove all of your stuff into main, and I see a lot of people in the Go world do this. Like functions are huge. People don't take the time to properly break things up into small parts. They're just moving so fast and trying to get so much done so quickly, and their programs become a giant tangled mess. How many people we got on? 12. Fucking sweet. So in the most basic sense, right, before we get to the actual refactoring here, I'm just explaining what I mean by good refactoring. So yeah, sure, we could shove printf hello world into main and do things this way. Or we can kind of encapsulate functionality into additional functions. So we can take this printf and move it up here. And that's just the same as it would be But now we have to actually call our new function. Now, another organizational tip is that if you declare functions before their definitions, then their definitions can go anywhere in the source file. So long as you have the declaration before function definitions that might call the function. For instance, we just moved print hello world to the bottom of the program. We declare it at the top. Declaring just simply says that, hey, program, we're going to be using this thing at some point, but we may not have defined it yet. So if we haven't defined it yet, just be aware that we might be using it and that the definition's going to come. And if the definition doesn't come, you can yell at me, and that's cool. Actually, we're not even going to make file. We're going to do this on the command. We're just going to do this straight up. So we've got our main.c. You do gcc main.c -o main. No problems. Now, if we were to try and compile that without having defined print hello world, of course, we get an error. Undefined reference to print hello world, right? And so naturally you'd be like, oh, well, now I got to go back and write print hello world, or in our case, uncomment it. So you might be noticing too that I move pretty quickly when it comes to actually doing things on the terminal, or at least relative to, like, I'm a much slower talker than I am like actually getting stuff done. But at basic, that was like the most simple example of how one might move code around in a way that makes it easier to break things down a bit and locate like where a problem might actually be occurring. Because very often you might find you have to detangle or navigate much larger structures than this. So speaking of, so one of the big refactors that I'm doing with this system that I'm building. First of all, let me show you the system itself. Find operation on non-socket. Why is it yelling about that? This was working last night. Oh, we never created the socket. Whoops. Yeah, speaking of, I was in the middle of refactoring last night. So we're going to continue that process now. So as an example of this, we have create socket and we can move that down to the bottom now. A lot of the initialization functions, I'm just wrapping up into new functions and just dropping them at the bottom. And over time, I'm going to pull these out into their own .h file. So far, we've done handle connection, handle request, parse arguments, int mutex, init mutex, and create socket. So for instance, next we would like bind socket in the same way. So let's go and do that. So we're going to do Zen mode, Copilot disable, void bind socket. Now, I was talking about globals previously, but so in this case, I am using some globals. But one of the other big refactors I was about to talk about is that in addition to this sort of process, I want to get rid of the dependency on C++ because I plan on implementing shared library reloading in this system, and implementing that in C++ is a fucking pain in the ass. So I'm not gonna want to do it in C++. I want to do it in C, which means where any sort of C++ functionality that I would be wanting to like rely upon, I'm gonna have to either find a solution or roll it myself. Address. Why did address fail here? Oh, so we need to actually make this global. Okay, compiles. So far, so good. Okay, let's test that out again. Okay, we have a server running now on port 8080, and I can do this kind of cool thing here where so first of all on the command line, I'm going to echo just the word hello, right? And then we're going to pipe that into netcat, which is a program that you can use to directly connect the ports on various IP addresses. Then we're going to send hello through a pipe. Basically reads data from standard input, then feeds that into the program that it's piped into. So if we execute this, at the top you're going to see stuff, and at the bottom here you're going to see stuff. So I executed it 3 times. You can see each of those up here. I wanted to do this in a loop. Handles it pretty good. Now, we're not getting a new line with the unrecognized verb thing, so actually that's a quick thing we can change. So every so often, Define doesn't release for a little bit. So if you like bound a port to a particular program and then you kill that program, it might take a little bit for the operating system to actually free up the port. So we just increment the port that we're running on. Oh yeah, so port 8081, right? So it handles that pretty good. Code basically accepts connection, reads a string, checks to see if different parts of that string match what I'm expecting. So, as an example of that, I have a command called connect. It says no address received, right? So now we're going to try and connect to, we're just, well, I don't actually have an implementation for the connect command yet, but step one is to like get the first commands in so that you can kind of develop a pattern for building a command parser. Is what we're doing. We're building like a backdoor into the server that we're building, right? Because we want to be able to like spin up multiple of these nodes and have them run and like wait for connections. So as an example of that, let's see. Now we have a second server running on 8082. And what we're going to be wanting to do is get the server on the left to connect to the server on the right via me telling it to do so. So we would want to do something like this and have it actually work, right? So notice here too that the thread count when I did that just went up to 2. So what's going on there? Well, that's actually intentional because the here, let me show y'all. So we are spawning a thread for every connection that gets made to the server, right? Because you want to be able to handle multiple connections, and if you're only working with one process and you're not spinning off another process for that, then you'd have a very slow server that can only connect or accept one connection at a time. So during the connection handling, if the received message fits these 3 conditions, if the verb is connect, if the address part is not empty, and if the port is not empty, now we could add additional checks here, such as, verifying that the address fits a certain format and whatnot, as well as the port. But this is at least a good start. So if these 3 conditions are satisfied, we're going to print this message, and then, or actually we return this message, but then we set up a structure that we're going to pass off to another thread. So this thread creates yet another thread, right? And one of the things that I'm going to be doing is reducing my reliance on C++ vector, because like I was saying earlier, I'm going to eventually want to implement shared library reloading, because one of the goals is to have these servers be able to pass their own updates around to each other so that they can dynamically like reload their own code and basically self-update. So like if I log into one node and I issue like an update command or something, I want that server to take the shared object library and then pass it around to all of its neighbors. And then I want those neighbors to update their code and then repeat the process until all of the nodes on the network are updated. But there's a lot we have to do along the way before you even get to that point. And one of the things we have to do is reduce our reliance upon C++ to 0. We have to get rid of vector and algorithm, replace it with our own hand-rolled data structure. So when we create this thread, we're calling handle request, which does this, because this is handle request is basically code that's its own, it's running its own thread, right? So I print the current thread count, just showing that like the thread count's increased to 2, and then, or rather, just the size of the threads. We don't even keep track of the thread count anymore. And then we print that we're handling the request. We grab the arguments from the parameter up here. The way that key threads works is all of the functions that you work with, you have to work with void pointers, and the void pointers have to be cast back into the data structures that they represent in order to get access to multiple arguments, right? So we print out whatever was sent, and then we actually delete the the thread from the vector, and then we exit. Like we also print like that we showed that we deleted it. So somewhere around here, this is where we would actually handle a request. So like what we want to be able to do is maintain persistent connections and be able to like exchange information in a way that like let me ask you this. If you have multiple nodes, you only need to maintain a connection if you're actively sending data, right? So we'd have to maintain a list of neighbors somehow. It's like if I'm going to get one node to connect to another, then we have to like keep track of who's connected to what. And one of the reasons that I'm writing my own data structure for lists is that we're going to have one data structure per data type that we have to handle. And two of the ones that we have to handle are pthread t, so that we can get rid of vector. And we also have to handle address. So because sock address in, this is like being used on every connection to like store the connection information, because this is where we actually accept it, right? So like the connection information gets written to the struct sock address, and then down here we use the inet into a function to convert it into a human readable format. So getting rid of vector, because at the moment I'm not storing the neighbors because we haven't gotten to the connection phase yet. But the connection that I'm making here is kind of like a backdoor connection. So we want to be able to distinguish, like, or do we? Is there any real difference between a forced connection and not? So, like, in our case, we're actually hard sending over a particular destination and port that we want to actually connect to. Um, and then, like, once we actually do that, what sort of information do we want to transact so that we actually identify the two nodes to each other in such a way that we save their relative locations? So in this list, implementation I'm working on, the the primary unit that we're storing is just an int. But if we wanted to work with different node types, for instance, instead of int, pthread t, something that we have to handle. All right, so first, now we're going to create a pthread, a node multi-thread type. Just called node. Actually, yeah. We're not even going to make a dynamic version of it yet because we're just trying to get the size of the node without any padding because I feel like it might be a clever optimization to allocate the nodes in a way where they're aligned so that we can avoid weird, memory alignment issues and stuff like that. So size, I don't know why Copilot thinks size of is %d, but whatever. Oops. We're going to make, and then we're going to do GCC node.o test.c. Okay, so node size is also 24 here. So that's good news because all I have to do now is uncomment that. Now the node size is 64. So we've padded the node size up so that it fits exactly into a cache line. So here's some info on the CPU that I'm running. And if you go down here, see cache alignment, it says 64. So under this premise, I'm hoping that my implementation is kind of a faster one than like a default one. So it's also kind of convenient that the pthread type is the same size as an int. Oh, no, not. It says pthread size is 8. But wait. Oh, and we never did the forward declaration. Right. So wait, if pthread is 8, shouldn't we like have to account for that here? Yeah, that's weird. Maybe it's doing some auto alignment thing just by me adding the padding in there. Um Because if we do the math, right? Like if we actually hand calculate this stuff, eight, 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 4, right? We get rid of the padding. It actually is telling us that all of them are the same size, even though probably going to get a different number when we add these together and print them out. Yeah, as expected. If we're manually doing it ourselves, we're going to get these numbers, but the compiler is doing some alignment for us in a little bit of a way. But by adding the padding back in there, like, because like 8, 16, 24 plus 40 would be 64, right? 8, 16, 20, it should definitely be 44, but what happens if we add that 4 in there? So now node size bumps up to 72. Now remember, if we update these values, now these read to actually have the same number, but even though that's what we get when we properly add everything up, the compiler is doing an additional padding on top of this now for the integer data type. So to fix this, we're just going to leave that F40 because now everything seems like it's lined up. So we added enough padding in there for the compiler to be smart enough to fully align it now. And So one of the goals I'm doing, I'd like to have with this is to be very easily able to switch out uh, the main definition of one for the other, because I'm also going to have to implement a socket address version, right? Actually, now we have two list types. Um, there we go. All right, so boom. So it should be in theory pretty easy for us to also a node of socket addresses. Now we're gonna need to verify the size of the socket because I think this might be possibly bigger or smaller. So, and we're not also we haven't created the appropriate stuff down here either. Oh yeah. So now in test.c, okay, so node 2 is 72. We've got too much padding, so we're gonna delete 4. Not enough yet. It's still lining up too high. We're gonna delete another 4. And we're aligned again. So actually, oh, we haven't finished grow yet. But the nice thing about this implementation is that we can have all of the memory in one spot. And if we need to grow everything, we can just realloc like this. I need to test to make sure that that works too. So if that works, then this code should also work. Okay, the size did not double as expected. Oh, right, because in the actual list code, when we push back, instead of returning false here, we need to just grow the list. So I should be able to call remove. Oh, we don't have a remove function yet. Why does it do this twice? Oh, it's doing the previous. It would be nice to also scale back if, for instance, we remove an element, like, because you're always going to end up with a lot. Like, there could always be like a downsize operation too, right? Like, if you end up with too much memory. Uh-oh. We've got some trash values. Um, all right, we're gonna start doing. We're gonna do this real incremental. 0, 1, 2. Good so far. Um, okay, so when the list gets grown, we need to print it out again. Uh-oh. So when the list gets grown, we're fucking up that first value that we're saving. Um, hmm. Oh, we're never updating the head. No, no, that's not right. Yeah. No, that next is not the tail. What? Uh-oh, seg fault. Seg fault. Well, isn't yeah, like these are just pointers themselves. So we wouldn't take the address. We could just point to node pool. And this one, yeah, we could take the address. Oh, seg fault again. Embarrassing. Where are we setting the head to be? Oh, oh, it's because we're setting the head and the tail to be the same thing. I feel like the tail should always be. I guess we should like print what the head and tail are as well. Oh, I guess wait, because let's see. We may not be crashing out till there. Yeah, we're actually not crashing out until after. Oh, it's maybe something about how we're accessing. Uh, 6. Head value 0. Okay, so it looks like it's doing something right. This dot get 0, 1, 2, and then it fails. All right, I got to piss. Hold on. All right, so what's the problem here? Oh yeah. That's what's happening. It's we never properly set the next on two, right? So like after the list gets grown, I wonder if I can like just manually update all the links, but I shouldn't have to do that. Like when we push back, oh, current size, it's getting okay. So if we're updating current size, oh no, let's see. Something's not linking properly, obviously. Um, yeah, how bad this breaks things. Oh, hey, that fixed it. That's not too bad. Make sure that it scales appropriately. Let's see. So we're doing 0 through 5. 0, 1, 2, 3, 4. We'll remove 3. Okay, that removes the list. All right, we're doing good so far. What else do I want? List clear. See what Copilot does here. Yeah, what happens if we clear list and we try to print the head and the tail? 0 and 0. Um, but of course, the size is 0, so I mean, anything that we would try to read at this point would be meaningless anyway. I was actually expecting garbage to be there. Um, but I also want to see what the max size is. So the max size stays fixed once it grows, which is generally standard behavior for a lot of stuff. I'm not going to, at the moment, implement resizing downward, but clearing the list was desirable. So What if we wanted to calculate how much data the list is actually using, right? Um, we don't actually need a function for that. Just like earlier, we can actually just use our a handy dandy macro. So um, out data size, or better yet, just data size. No, wait. I guess technically this is true. Um, but the max size would vary based on the list itself. So yeah, we would want an actual list. Size of node type times list pointing to max size. Accurate. Um, what if I wanted to calculate this in, well, we'll start here. 384. Holy shit. Is that right? 64 times 6. Yeah. So to store, under these, with these additional capabilities, to be able to, you know, swap numbers in and out and stuff like this, we're storing 64 bytes for every node. So for every number, right? So for every integer, which is okay. I mean, it's under a kilobyte for 6 empty values. Let's do something interesting. Let's scale it up a bit. Default list size of 1 million. My baby's getting up, so I'm about to take a break. Also near her din time. Maybe we don't want to print everything out because that'll take a while. So actually, maybe we should just do 200, maybe 100,000. Here we go. All right, so that was relatively fast. So to store 200,000 numbers in this way, uh, at peak capacity took 12 megabytes. Um, Now remember that we're padding things up, right? Like, if I were to go into node.h, comment out the padding, it's still using 12 megabytes. But also notice the data size bytes is different, I believe. We were testing with just regular nodes. Oh, wait, no, it is actually coming up with the same value. Huh, interesting. Hmm. So it seems like the compiler might be doing something underneath the hood, or we can't necessarily trust the value that size of is coming back with. Because for both of those changes, I would expect a variance to be occurring. Because remember earlier we talked about 8, 8, and 4, so that should be 24, right? Ah, that's different. Okay, so we did have to clean. So when we get rid of the padding, now we're using only 4 megabytes. But this structure is no longer precisely cache aligned. Because 24 times 3 is 72, which is just past 64, which is, of course, again, size of the cache line, right? So, in other words, we had to introduce padding, right? Well, rather. So like, remember that the data structure uses 24 bytes, which is 4 plus 8 plus 8, right? Sorry, 8 plus 8 plus 8 in the other case. We're working with the integer version. The integer version uses 20 bytes on its own. So we had to introduce 40 bytes. So we actually have the same problem as we had. So even if you change this to 20, 20 times 3 is 60, but 20 times 4 is 80. So if you had 4 nodes right next to each other, the fourth node is no longer going to line up with the cache line, and some of its data is going to end up in another cache line. So when the CPU goes to fetch the information, it's going to go, where the fuck is the rest of my shit? And it's going to go, oh, we got to load the next cache line to get it. Oh, okay. Which is a lot slower than just being able to directly grab the data without having to do that shit, right? So we're basically kind of forcing the CPU to be like, yo, we got this shit and we got it in fucking line, bitch. So eat that. And that's a good thing, right? Like, that's actually gonna make our program faster. And we can even do benchmarking on how fast shit runs in one version and the other. So building this really tight, data structure is going to be useful for, again, getting rid of vector over here. Because if I get rid of vector over here, then we no longer need C++, right? And if we don't need C++, then I can go ahead and implement shared library loading. So that's going to be coming in future videos. I'm going to go ahead and take a break here to charge up, feed my baby, and probably do some coding off stream. Really big shout outs to like the holy fucking Christ, we got an actually ass number of viewers here. What are y'all doing? My God, thank you. This is fucking amazing. I did not expect to see this many people. I just have not been paying attention to chat. Y'all are actually chatting. This is fucking sick. Y'all fucking rule. Goddamn. Thank you. Thank you again. Let me go and do some check-ins before I go, right? Let's actually call this a save point. Holy Christ on a stick cracker. Good Monday. Fucking A. I love you guys. Okay, wait. So Red King's actually up to date, but we need to make the list. And see, we're doing it with an int first, but like we're generalizing the process because we can just copy paste the data structure and swap out one data type for another. So you can have like multiple different list types. So that way we don't have to worry about like dynamic fucking typing or anything like that. And we can just raw dog our data structures that way, right? And being able to do that will allow me to more easily do the shared library loading, because it's a fucking pain in the ass with the C++ name mangling. I hate dealing with that shit. It's way easier in C. So being able to load the library dynamically on the fly will not only help develop, like speed up the development loop, but at the end of the day, one of the major goals of this project is for the servers to be able to distribute their own signed shared object libraries and dynamically up themselves on the fly. It's a little bit of work to get there. So let me go ahead and make this commit. I like this license personally. Do what the fuck you want to. Public license. Came out the same year that I started going to college. I say started because I'm actually going back. I'm going to go back for my PhD. And the work that I'm doing right now, I want to be the inception of whatever research it is that I do in a doctoral fashion. Like, it may just seem like I'm fucking around it a little bit at the end of the day, but at the same time, a lot of projects kind of start off this way. You have to start, like, if you want to do research, you have to dig in. You have to really get your claws deep into whatever it is that interests you. And I saw this thing in VX Underground that was like talking about a decentralized network of servers that can be categorized as something called a small world network, and information can be shared and distributed through the system in a very efficient way, in such a way that it does not take very long for any two nodes that exist in the system to actually communicate with each other without actually being directly connected, which is fascinating. And I want to explore what can be done with such a system for good and for evil, if not to figure out better ways to fight it, right? Like, any technology can be used for malicious purposes, and part of the fun of being a gray hat researcher is getting to play around with some of those things, because I don't think you can be a good white hat if you're not also willing to be a good black hat, right? So that's kind of the evil dojo philosophy at the end of the day. We're not actually evil here. We like, playing the bad guy in movies. So that said, I love you guys again. Wait, we have to finish committing, right? Oh wait. Every GitHub repo that I've ever done just about starts with a commit message for the first Kermit. The Kermit. The Kermit. I don't know if I have a Kermit voice or not, but I think if I just try to emulate Jordan Peterson, I can kind of get something that sounds in the right direction, but I'm not Canadian enough or have balls that haven't dropped far enough, from the center of my center of mass, because, I'm a lobster, and lobsters walk upright. And that means that they're superior beings to human beings and have evolved intelligence beyond our own. That's not quite Kermit, right? Like, that's not exactly. I got jokes. I got fucking jokes. What's up? Let me answer some of y'all's questions too, right? Before I go. Let's see. Mblenszewski asks, what is this server for? Why not use an intrusive list instead? I'll have to look into what an intrusive list is. Having the list node be a separate struct you add to each type you want to have a list of allows you to then have a generic from node macro to turn a pointer to the member list node to a pointer to the parent struct. So the reason that I didn't want to do that was I actually thought about doing a define macro to be able to switch between types, but I want to also be able to have lists of different types without having to like switch via a macro. So, and I'm sure that there's a way to like write a constructor for this, right? But I think it's also useful to actually like have the real objects. Why not use align AS64 to force alignment and add the padding automatically? I actually ran into that method while looking at Stack Overflow, and I honestly just haven't done enough research to sit down and play with it yet. Um, I'm kind of doing things in a very old school way at the end of the day. It's more like there's no reason that I couldn't try doing that either and even compare performance. Um, that could be certainly something for exploration. What is the setup to get auto completion with Vim? I can show you. So for autocomplete, let's see. This is my Lua init.lua for, and a lot of this came baked in with the bootstrap Kickstarter, whatever, that I think his name is Tej Dev uses. Which is how I initially got started with NeoVim. I actually am a Vim writer of like, how long I've been using Vim now? Fucking 16 years, 17 years or something like that. Um, so so if you look up this dude, nvim-cmp, this is like what handles all my autocomplete stuff, I think. Because I have like two different autocompletes that kind of like come up. One of them is like based off the LSP, which figures out like what methods and functions you have across your source files. And I also have the GitHub Copilot autocomplete, which does stuff in line and doesn't really give me like a drop down menu or anything like that. So I think the drop down menu stuff is actually this thing. See what else. Yeah, I'll play around with the size and stuff. At the end of the day, I'm trying to strike a balance for like readability for not only you, the viewer, but myself as well. And the larger that code is, the less you can fit on your screen. And as a programmer, you want to minimize how much movement you have to make. And that includes the movement of your eyeballs in order to make it so that you can rapidly locate things. So I do apologize if the font was too small, but we'll try to strike a balance. Like with this many viewers, we could actually do a poll on what everybody's preferred font size and terminal resolution could be for actually streaming purposes. So I'd be interested to get that feedback from you guys because I do want to create a good experience when I am on doing this stuff. Someone says pluripotent hematopoietic stem cells. Someone asks, what's your Vim theme and color scheme? It's Tokyo Night, which is down here. This is also a Vim plugin, and you can actually switch out color schemes. So like I can do it. I think I still have telescope on here. Yeah. So I should be able to like you can actually like go through this list and hit one and it automatically like updates, which is awesome. Actually, Tokyo Night, I don't think this is mine actually. I have something else that's actually overriding that. All right, guys, I gotta go. Thank you again for joining. Can't believe we got this many people watching right now. Y'all know where to catch me. I'm on X, shit posting every so often, spamming my own ads, and like I said, I gotta feed my doggo, feed myself, and do some non-computer stuff before I get back to it. But thank you for joining. Really fucking appreciate it. Didn't think I was gonna get this many people, but I should guess every so often, and I should start expecting it. Y'all take it easy. Peace out.